Right, we will start. So welcome everybody. We've got quite an interesting webinar today on riveting and joining processes, and I'm delighted to introduce John Stanners from Stanners Group, and we've our very own Jerry Braddock from the MBRA as technical manager. So John, welcome.
Hi there, you're right.
Not bad, thank you. So before we go into all the technical jargon and all the other pieces that we're going to share with the audience today, would you mind telling us a little bit about Stanners and how you came to work for Stanners, and a little bit of history, if you would?
Okay, family-run business, over 8 years old. Originally started by me granddad as a sign writing business. Then we got into paint distribution, PPG, Glazerate. Along came that with the equipment, obviously infrared drying. And then when my uncle started, that's when we started getting involved in the welding. And then obviously as technology's moved on, it's been businesses, not so much on the paint distribution, but a lot more on the equipment, live equipment, and most recently riveting equipment. Myself, I've been involved since I was probably 4-year-old, labelling paints of PPG from as long as I can remember. And then for the past over 15 years, I've been on the road demonstrating equipment, working with training centres, etc.
Yeah, no, cool. I mean, I'm pleased that I've known Stanners for probably about 7 or 8 years now. And you've come in and diffused a couple of situations for me, which I'm very grateful for.
Yes.
And I have to say, the amount of knowledge through Stanners on welding and other types of technical repairs, just every time I talk to yourself, your dad, or Michael, it's staggering the wealth of knowledge that you actually hold. But this year you've come on as a partner member for MBRA, and we're pleased to share this webinar with you. So without further ado, we're going to what riveting's all about. So why riveting then? Why couldn't they just carry on welding and good old repairs would just stay the same?
First of all, if we take the material, say aluminium, it can be spot welded, but you need such a high amount of power. Modern day spot welders are about 14,000 amps. Really, you need to be about 20,000 amps, 20,000 amps to spot weld it correctly. And currently, the UK power supply and the technology in spot welds is just simply not there to do that welding. There is, unless you have, say, a transformer or very high upgraded power supply. There is certain technology which can actually do it, but the transformers are so big in the units, it means it's impossible to actually weld, for a panel technician to use them.
Yeah, so the mobility is not there.
Exactly.
And I'm guessing this solution allows, a worldwide solution to repairing various cars that have, various substrates on them.
That's
don't have the electrical supply that we enjoy in the UK.
Correct, that's right. That's one of the reasons why BMW started the cold repair process with steel.
All right.
But it wasn't just because of that, it was also to stop less corrosion so you don't have to take the coatings off the new panels.
Yeah.
And also what we're getting with other manufacturers is you've got steel going right next to aluminium, where at the moment it's impossible to weld together. But
right.
There's not just one reason, there's a numbitude of reasons why it's going more down the riveting route.
Yeah. And what I would say at this point is, obviously, if you've got self-piercing riveting and other riveting solutions, then brilliant. But if you haven't and you're frightened of it, then hopefully this webinar can change your mind and future-proof your business. So we'll go on to the next slide, which is the types of rivets. And this is far too technical for me, John. So if you walk us through this one.
So this is what BMW started using. To be honest, 20 years ago, Jaguar started using on their aluminium cars, Audi A8. The very first one, which had the aluminium quarters and body shell, was used self-pierce rivets in the method of repair and also in the factory. But it was more BMW 10 years ago when it started the cold repair process, where self-pierce riveting came, say, to the forefront and to the highlight of the industry.
Yeah.
The beauty about it is there's no drilling. It's also known as a punch rivet. It's one of the things I want to get across in this webinar is a lot of different terminology for different types of rivet. So self-pierce rivet is also sometimes called a punch rivet, but they're both exactly the same thing.
Okay, and one thing I'll just highlight now then is that this webinar is being recorded, so it will be going up onto the MBRA website. So if anyone misses it or you want to refer back to it, then you can. Along with the presentation will be made available on the MBRA website. And at the end of this presentation, we've got John's details, both mobile and email. So if you have any questions of a technical nature and you want some assistance, then John is volunteered to do that for us. So sorry to interrupt.
Oh, no problem. The other thing I'd like to say, with all types of rivets and even self-pierce rivets, you can see in the picture, you get different diameters, different lengths, and also different coatings on the rivets.
Yeah.
The manufacturers, as always, have decided to use different size rivets on their vehicles. So that always means different types of dies.
Okay.
If you do purchase equipment, you might find you've got an equipment which can do BMW self-pierce rivets, but it can't do the Jaguar self-pierce rivet.
Yeah, and on that, sorry, John, on that illustration, it looks like that rivet isn't actually punching through the back end of the metal. It's just punching through the front surface and grabbing hold of the back one and pulling it back.
That's exactly spot on. In the rear die, it's very important to notice, make sure that's always clear of glue.
Right.
Because once the glue dries or sets, it's just as strong as metal.
Right.
And if that rear die isn't clear and clean, the rivet doesn't form and set properly inside the rear die.
Okay.
So that's another thing. Another thing about self-pierce riveting is simply just, like I say, just the cleanliness. And it does look, on one side, you do have the bulge in the back, but on the outside, which you're looking at, it does look like a spot weld.
Yeah, no, very good. And again, methods will point you in the right direction when it gets too complex. Okay. And then some more blind rivets. These are probably more your traditional rivets, are they?
Yeah, more traditional rivets. So again, terminology. People, they are pop rivets. You know, they are classed as pop rivets, but now the method of calling them blind rivets, basically because you can't see the other side. Technically, when you're using them, you can't see the other side of the rivet. Whereas in areas where you can get access with the tool, you'd use the tool, which is two sides. But in areas where you can't use the self-pierce rivet, you put a blind rivet in. These come in different sizes, different forms. They're all structural rivets. I should never say it's a non-structural rivet, but you do get different strength.
Okay. So what traditionally is the rivet made of then? So the actual core, which is pulling the surfaces together, what are they made of?
There is different materials. Sometimes they are stainless steel, and sometimes there's tungsten built into them, but they are all. And quite often, what you find is the manufacturers won't tell you what actual brand of rivet they're using. They just put it under their own part number.
Okay.
Because they don't want to know other manufacturers to know what type of rivets that they are using.
Ah, okay.
But what I should say, especially the next side, the structural brake stems, they are very strong rivets, and you do need high-powered tools to pull the rivet.
Okay, that probably takes us on to our next slide then.
Yes. So these are two popular brake stem riveting tools. One's by Advil, one's by Catsipia. basically they have 1.9 tons of pulling force. The disadvantage of these riveters that we're finding now is sometimes struggling to get access into certain areas of the vehicle.
Yeah. And how are these guns operated then? Is it compressed air? Is it a special gas or?
Just simply compressed air and
Right.
compressed air supply.
Right. So any traditional body shop can plug one of these in. So long as you've got the training, which is paramount,
Correct.
then you can crack on and use them.
Also, what I'd like to say is what we're noticing as an equipment supplier and service agent, we're finding that especially in, say, manufacturer-approved shops, and this will then stem into, say, normal insurance shops, these tools are starting to get used a lot more, and we're noticing the wear and tear on them.
Yeah.
For example, if the tool has to go back to factory to be serviced, whatever reason, we do have a couple of loan tools which we can lend people.
Right.
We are finding people now are doubling up on equipment.
Right. Just so they got a spare in case the one fails.
Correct. That's right.
If the jewels have worn down or whatever. Yeah.
Correct. And we've certainly noticed that, especially in the last 2 to 3 years, the amount of servicing and breakdowns that were happening on what we call untraditional.
Okay.
And it's fair to say that on each of these guns, you've got the catching device at the back.
Yes.
Because the pins will shoot out at great speed.
So
that's a very good point.
You know,
important to put the cap on the back then.
Absolutely.
Yes, because certainly I know on the Mercedes rivets, those structural brake stems, if you don't have the catchment on the back, they do fly out the back, and if you're not wearing safety goggles or shield, it will cause some damage.
Right. So again, training paramount before you pick one of these up and try and use it.
And PPE.
Yeah. Okay. So a TKR brake stem tools looks a little bit smaller, but it looks more expensive.
It's a lot more expensive. It's about twice as expensive, and that's just the attachments, because this tool fits into the pump of the self-pierce riveting tool.
Yeah.
So it's actually got more pulling force. It's 2.5 ton. But the beauty about it is it spins in all different angles, and it can reduce to a lot lower size and can get into a lot more awkward places.
Yeah.
Quite recently, I've had to help some customers, and we're not talking a lot of rivets. It might only be 4 or 6 rivets where they couldn't get access with their traditional brake stem tool on the slide before. The pictures up in the top right there, that's actually on a Range Rover Vogue, where it was riveting into the rear chassis leg. There's only 4 rivets. It actually meant that they didn't have to take out the quarter panel off on the vehicle.
Right.
Even though there's only 4 rivets, it probably saved the quarter panel itself.
Yeah. So again, methods are paramount, not only to understand which rivets you need for the repair, but obviously to save other panels. If you follow the right procedures and the right equipment, then instead of total loss in a vehicle, you could save it and have a repair, which in these times with volumes being low, that's quite crucial, I think.
Right. And the other thing I'd say is when it comes to these riveters, that repair that we did, you probably could have gotten in at a bit of an angle, but do you really want a structural rivet being put in at an angle where it's meant to be 90 degrees straight to the sun?
Yeah.
Thankfully, the technician had the sense to make the phone call.
No, and I think in this day and age, if you don't know, then ask the question. It's just so crucial to make sure that you're following the right methods and you're getting sound advice to repair the cars correctly. Now, how often do you think a repairer would use one of these? If they're JLR approved, probably frequently, but if you're not JLR approved, I wouldn't imagine you're going to have a lot of use for it.
No, not currently. The other repair, it was which I had to help out. this is only the jobs that I find out about, was a Audi Q7 in a up in the strut top, where again he couldn't get the tool in. However, we had to lend a riveter because their riveter failed to a local customer. I went in this equipment, and he was doing an F-type leg. What he realised was he would have had, if he'd had this tool, it would have meant of doing a lot less stripping of the vehicle.
Oh, right.
So he'd already stripped the vehicle, his tool failed, we went and helped him out with this one. And when he got the tool, he said he could have done a lot more less stripping on the vehicle had he had this tool in the first place.
Right. So more efficient, possibly less breakages, maybe.
Yeah.
Well, it seems to me like there's probably a market for hiring these out then, John.
There is, and we do have to be honest, we do have an NBRA customer who does hire them out, Barry.
Yeah, Peter Garth.
Peter Garth.
Right.
He does hire out jig brackets as well. I've sold him about 5 or 6 of these riveters.
Okay.
And he does hire them out.
Right. So I mean, again, if you're interested, if you get a job in and it's a JLR or something similar where the methods are saying stipulate use this type of equipment, then rather than going to the full extent of buying one, contact John at Stanners and he'll put you in touch with the right people where you'll be able to facilitate the equipment, so long as you're competent in using that equipment. So you will have to have the training to be able to use it, I take it, John?
Yes, you do. Put it this way, if one is understanding the riveting process, and 2 is understanding the equipment. Don't understand the equipment, it's probably cheaper to have the training done rather than paying for the breakage on the hiring the riveting equipment.
Yeah,
makes sense.
It's almost future-proof your technicians by getting the training, and as and when you need this piece of kit, you can hire it and crack on with the repair.
That's right. And later part of the presentation, there is actually a proper qualification which covers, which we'll talk about, which covers all these rivets.
Okay. And then we're on to flow form rivets.
Okay, so flow form rivets, they're available in steel and aluminium. They were first used by Mercedes in methods of repair, but they've now actually started to creep into Jaguar Land Rover methods. Again, they come in different lengths, different diameters, but the beauty about flow form rivets is, which we'll touch on a bit more, is you use it when you punch a hole, when you punch a self-pierce rivet out, which is done in the factory. If you use a self-pierce rivet, again, you've got to go next to the original hole, whereas with flow form rivets, it uses the same hole. So you're not reducing the amount of material being lost in the vehicle. Okay.
So you're not perforating the panel then by punching through loads more holes.
Right, that's right. BMW, for example, haven't started using flow form rivets yet, but on their first cold repair process, which was the Mini, they said using self-pierce rivets, it could only ever have 3/4 panels.
Right.
After that, it's replacing the inner or the car's written off. Whereas using flow forms, you don't have that issue.
No. Okay. Otherwise, it'd be a lottery as to whether it's been in previous accidents, and if you get the third one, then you potentially would have had to put it in the bin.
Yes, correct.
I can see from the pictures that they're marked up S and A to, stipulate that they're either steel or aluminium, which makes it easier. But I got to say, I mean, it seems quite complex at this stage for me. And I've got some questions, but I'll leave them until we go on.
I'll be honest. Yeah. No, the other thing I'll say, in Mercedes, they use the steel S1s in steel areas. Again, it's on the methods. They use the aluminium ones in aluminium areas. However, Jaguar Land Rover are only using the steel ones on their aluminium vehicles.
Oh, right. That's interesting.
Yeah. So that's only happened with the new Defender. Again, because they're running out of space on repairs. The Jaguar self-pierced in the factory, on its defender, they found areas that there's not enough space to rivet next to the original rivet. They've gone flow form rivets, and they're actually starting to change methods where these flow form rivets, previous
Right.
method might be self-pierce, the new method might be flow form.
Okay, silly question then, and you might get a few of these from me. So they're going to use steel flow form rivets on aluminium panels.
Correct.
How about the reaction?
Yeah.
That is where but remember, you're always bonded first. And
Right. So they're insulated from contamination, are they?
correct, that's right.
Right, okay.
On the other thing is, when we say steel, this is not what I'd call a mild steel rivet. It's a very high quality type of steel, so you don't get the reaction like what you typically have normal steel against aluminium. But the bond should be plenty bonding glue on there to stop the reaction.
Okay, cool. So we're going through processes now. So BMW, I know you've already mentioned BMW, but talk a little bit more if you would, John.
Okay. Another item I like to cover is when we've say gone to spot welders 15 years ago, we went through a stage where people were almost having to upgrade the spot welder every 3 years because steels were moving on so fast. And I hate to say it, but we're almost at that point now with riveters. BMW is a fine example. They've had the first power riveter, then the air riveter, then they went onto the TKR riveter. That TKR riveter, which is what we call the P&P 90, is now no longer good enough, and they've actually gone back to say spot welding in certain areas because the rivets and the tool doesn't have enough pressure to go through some of the areas.
Right.
There is equipment out there which will do the job now, but because of COVID, etc., and new types of rivets, I don't think they've been tested properly.
Right. Okay.
So what we are finding is the equipment levels is moving on very, very quickly at the minute when it comes to riveting.
Right. So in the methods, are the manufacturers updating their methods accordingly to their changes in processes for doing it?
So
right.
BMW used to be a completely cold repair process.
Yeah.
Now you have a mag welded joint, say on the C or the D pillar. That they've done that because the filler that they were using, technicians weren't getting it right, so they got a lot of cracking, especially on like the M range cars. They've got spot welding down like the B post and the till area because the self-pierce rivets that they're currently using don't have enough strength, and the riveter doesn't have enough pressure to put the rivets through the B post area. And then you've got self-pierce rivets around like the door aperture.
Right. That sounds pretty complex to me.
Yeah, it sounds like we need a bulletin on that, don't we, for all of our members?
Well, I think the point I was going to go to, Jerry, is that just because you did one of these 2 years ago doesn't mean to say the same process stands today.
Absolutely.
So
absolutely.
if you've selected a method and you've kept a library of them, don't try and fool yourself that it's still up to date 2 years later, because the vehicle manufacturers may have updated them. That's all I was going to say.
Yeah, 100%, and that's just being proved with that's not BMW, that's Jaguar as well. Yeah,
no, I know. So just out of curiosity, how much is that little TKR PMP 90 down in the bottom right hand corner then, John?
That's what was automatically issued to the BMW network it'd be about 10 years ago now, when they first started their code repair process. That would have cost the BMW repairs around about $2,000 to $2,500 plus the VAT.
It's not so bad. I've heard of worse, being on the network and being mandated to purchase equipment.
Yep. But the later equipment, which we'll get to, is a lot more expensive.
Yeah, well, it wasn't going to burst anyone's bubble just then.
Okay.
Work high.
Yeah. Okay, so setting 3.5mm BMW rivets then. So we've got a video on this. you want me to play the video now, John?
Yeah, go ahead. So just remember, that's a self-pierce, or otherwise known as a punch rivet.
Yeah.
These 3.5mm ones, again, the BMW methods are very, very good. They'll tell you exactly the amount of rivets, where to put them, and what size rivets. Thankfully, BMW only have 2 types of self-pierce, or otherwise known as punch rivets. One's a 3.5mm and one's a 5mm rivet.
Okay.
The nice thing, you always got to remember is it's always got to go through 2 fresh bits of metal.
Yeah.
So you can't go where there's a hole on the, say if it's on a second quarter panel, you've punched the rivet out, got to rivet next to the original hole, if that makes sense.
It does, and I think that's going to get even more complex as we go through this presentation. So
Yeah.
bear with us. This is the 5mm.
Yep. So exact same process, just a bigger rivet. Tends to get used on three laid areas.
That machine makes it look very simple.
It is, and to be honest, it is a simple. There's a few pointers to always remember when you're using the machine in terms of tightening the heads, etc., keeping the heads clean. But even though there's one thing with this is I want to get across, providing you've got the information, the equipment and training, it is actually a very simple process.
Yeah. I mean, I assume, I'm not going to say it's similar to spot welding, but you go through the methods, you understand how many spot welds you need to put into the panel, where to put these spot welds, and it will stipulate that you need to keep the welding tips clean as well. So, you know, it's a process that our repairers will be familiar with. It's just changing that mindset slightly.
And the nice thing is you haven't got sparks flying around, and it is cleaner.
Yeah.
Because there's less preparation in the panel.
That's the same one, I believe.
The other thing I'll mention is make sure you do wear a full face visor shield when using this equipment. Yeah,
because I thought you said that sometimes if there's a defect with the rivet or something and it goes wrong, then it can come out at a hell of a rate of knots. So PPE essential.
Yes, definitely 100%.
Yeah. Okay.
Because so JLR, so they typically have always used self-pierce rivets. If you can see there, you asked about cross-contamination. On that particular rivet there, that's a coated rivet to stop cross-contamination.
Right.
Some rivets are coated, but if we look to the diagram, that's page 7 of 9. There's 9 pages of different types of rivets that they use on their repairs. BMW have a blind rivet, a 3.5mm self-pierce rivet, and a 5mm self-pierce rivet. Jaguar Land Rover have tens and tens and tens of different types of rivets.
Yeah, that's why I said it was going to get a little bit more complex. I assume the fastener identification, that would be in the methods also, telling you what types of rivets to use and where to use them.
Yes. Well, it's in a different part of the method. So when you print the method off, it won't have this attached to it.
So you got to go searching for that.
You've got to go searching for that, and it's very crucial because this with Jaguar Land Rover, it'll tell you what type of rivet.
Yeah.
Part number, the force that you put the rivet in at, whether it's 25 kilonewtons or 50 kilonewtons, and then also what type of anvil that you use. So on the picture, you'll see there's one setter, but then you have what we call a deep bottom flat, a shallow bottom flat, and a pip bottom flat.
Yeah.
That is all on that fastener identification activity.
Okay. All right.
We do have copies of it, so if anybody does get stuck, that it could be something that we could send out.
I think if I was setting up and I was a repairer and I'd invested in the kit and one of these jobs come in, I'd be calling you up and just asking for advice all the way through until I got confident with it.
And to be honest, that's one of the things that we do is sometimes people buy the kit and they might just say buy the BMW heads because that's the most common that they do. They might get a Jaguar Land Rover in.
Yeah.
And if you've bought the kit from us, we will, providing if you can give you a few days notice, we will always come out and help run through the first job of a different type of vehicle.
Yeah. No, I'd definitely take advantage of that.
Yes, and we do not charge that either.
No, okay, that's good. Shall I start with the videos then, John?
Yeah, go ahead. So this is punching the rivet out. You can either use the tool to punch the rivet out. It's being self-pierced in the factory. The other option is by grinding or belt sanding the top of the rivet off. But what you can see is it does leave a hole at the back of the panel.
Yeah.
Which would then typically be filled up with the glue.
Right.
On the repair.
Next one.
Yep. Also, I just wanted to mention on the pictures in the bottom right there, that is what the self-pierced rivet looks like once it's been removed. And no, it cannot be reused before you ask.
Oh, that's a shame. Especially with the price of rivets. Never mind. But that's that again, those videos just make it look so easy. I mean, if you're there with a boron drill bit or trying to drill those out, it just seems like a no-brainer to, if you've got to use that tool to get the rivets in, I'd use it to take them out as well.
Exactly.
Yeah.
Another note I'll make is these punching tools, again, if you're not 90 degrees onto the panel, cause any damage to them. There was a previous tool, I'll not name another manufacturer, but
yeah,
the ends weren't as strong, and it was a tool which was mandated to Jaguar Land Rover, and on every job it was actually put onto the estimate as a part for a brand new head, because people were going through the anvils that much on the previous tool.
How much are the anvils?
On ours, you're talking roughly around about 60 to 80 pounds, but on the other tool, they're about 150. Like I say, what body shops were actually doing is then putting that down on every job part.
Right, which is an extra cost to the insurance company, right. Potentially. Yeah. All right. Well, I'm glad you found a solution for that one. Oh, on that. There you go. So, rivet installation.
This is just to show when you put the new panel on, when you're fixing the new panel, you've got to rivet in between the holes.
On fresh metal.
On fresh, always going through fresh metal.
What do you do with the old holes then?
Obviously deburr it with a belt sander.
Yeah.
And you basically let the glue fill the hole, and that's it. Possibly a bit of filler as well.
Right.
Just to smooth it off.
Simple as that.
Simple as that. But then say if it comes in for another repair, you start running out of space.
Right.
So if you've had a car that's been repaired before, depending on the method, say for example BMW, it is worth just lifting up the seals and just having a look around to see if it's had a previous repair done before, because
right.
we'll also help you order the correct rivet when it comes to doing the repair.
Yeah. Well, I'll come on to that in a minute because I've had experience of that. So you've got your TKR at the top, the XT2 kit, and then you've got the Advil ESM50 at the bottom. Both do the same job, just different manufacturers?
different manufacturers, but again, time's moving on. So
Yeah.
the Advil ESN 50 means it can do 5 tons of force. But it can't do it doesn't have a blind rivet attachment to get into really awkward areas.
Right.
The TKR XT2, it basically means 10 tons of force, and it's 2 ways, which will come back in the next slide.
Right. Okay.
And what Jaguar is finding now is certain joints, not many, which are at 6 tons of force. So if anybody who's buying the Advil, you'd be pretty much wasting your money, because you might get a Jaguar in where it can't actually do the job for you.
So rather than just assume you know what you want, talk it through with you, discuss the type of work that's coming through the workshop, and then you'll advise on what tool's best for their work coming in, I guess.
Exactly.
Yeah.
Because sometimes there's no need to go all the way, all singing, all dancing like what we have with the JLR.
Yeah. Okay. Done that. Right, over to Mercedes-Benz then. And you go on.
Yeah, so Mercedes, there was a rumour that we were going to replace spot weld with the flow foam rivets, but that hasn't really occurred.
No.
The steel, when I spoke to training centres, the steel flow foam rivets were only getting used on areas where the car would be written off. But aluminium flow foam rivets, they're being used on like the Mercedes SL. So it's still a prestige car, but it's, you know, you could quite find it in a mainstream body shop, if you know what I mean.
Right. Yeah, definitely.
Yep.
I was just going to say, I mean, I can remember a repair coming into a workshop, and the technician was all set. He bonded in preparation, offered up the new panel, started to work on the vehicle with a set of rivets, and then found out there was another set of sized rivets that they required, but they hadn't turned up.
Yes.
And it turned out to be a bit of a pig's ear, to be honest with you, because you had to take the panel back off. Obviously, the technician was throwing his toys out the pram, and for good right too. But it's all about the preparation, I guess. Before you start doing anything, make sure that you have the right rivets, the right bonding agent, your riveters working. I know it sounds really simple, but I've seen this firsthand, and I've seen how pear-shaped it went.
Yeah.
So, what advice have you got, John and Jerry?
Well, you know, this is it. If you don't read the methods and you don't have experience, you can easily make these mistakes. And really, once the sealer has gone off, it's very, very difficult. You've got to then heat it up to soften it, to pull the panel off and start again.
Yeah. I think, and then they couldn't get the rivets for a couple of days, so the car then had to go back outside, cover it up, and then it was just, you can tell it wasn't the best of jobs going through the workshop.
Yeah, no, I perfectly agree. When it comes to, even though it is a clean process, it does take long. I say it does take longer than welding, because even just aligning the panel, you've got to put the panel on. Say drill your holes for your blind rivets. Take the panel back off. If you've got a tailgate to fit and a door to fit, you've got a lot more preparation when it comes to alignment, when it comes to your job compared to welding.
Yeah.
Right. And I assume the methods, not the methods, but the estimating for time will accommodate that.
Depends how much experience. I'd say on the first job, no, but technicians who've done a few jobs get the hang of it. But I'd say on the first job, if you're inexperienced, then I would say possibly no.
Put some more time aside.
Yes.
Yeah. Okay. Cool. Sorry, John. You carry on.
Yeah, Mercedes. Like I say, the aluminium flow forms, they They are used more in the prestige cars. I mentioned Merc SL, GT, was used on the SLS at the very beginning. They quite often use blind rivets, so structural brake stem blind rivets on the sill areas, where again you do need a high power tool. But one thing where I often get questions is, or people might say, I need to hire a riveter, put a Mercedes in. To be honest, I think it might actually nearly happen with you, Tom. And people think, oh, I need a self-pierce riveter. Quite often with Mercedes is you just need a good, powerful brake, a good, powerful pop riveter to do these rivets. But some things estimated flags up, or it's a rivet and repair method. They instantly think it's self-pierce rivets, and running around trying to hire a state-of-the-art self-pierce riveter where all they actually need the blind riveter. I have had that. I've had that scenario quite a few times.
Right. So again, call you up. You'll soon put them right on what type of riveter they need for the repair.
Exactly. Yes, that's right.
I reckon you're going to be busy after this, John.
Actually, that'll be quite nice.
Right then, so 3 different processes from Mercedes-Benz: punching, countersinking, and installation. So we'll start off with the punching then.
Yep. So first of all is the punching of the hole through the new material. So this, when I said it's a two-way process with this riveter, there's a hydraulic to move the piston forward, and then also hydraulics to push back. That punching hole, you don't have to wiggle it to get it out. It automatically just retracts.
So don't fight it then, is what you're saying.
Right.
Just let us do its job. Okay.
So with these flow form rivets, you punch all the holes, then you do countersink them.
Yep.
And then you put the rivet in with your fingers and crush it. So what you can see with flow form rivets, so bear in mind these are used Jaguar and Mercedes currently.
Yeah.
It's a lot less harmful to the vehicle because you're using the existing hole and you're not removing too much material, but it is a lot longer process.
Okay. So, but it keeps the vehicle more in its manufactured state.
Correct.
Sorry, John, go on.
Yeah, no, that's the main advantage is keeping the vehicle like how it was when it was from new. And once you've done that flow form rivet, again, if it needs another repair, you punch the same flow form rivet out, and again you can use the exact same hole on a second repair.
Okay. Cool. Should be on quiet. Right. So all those go. So VW and Audi then.
Right. Again, so they use. You've got the choice of a self-pierce rivet or what they call solid rivet. The solid rivet has the same process as a flow form rivet. However, it works completely different because the solid rivet expands from the inside, bulging into the panel, whereas a flow form rivet is almost wrapping itself around the panel on the outside.
Okay.
Now, Volkswagen Audi, the methods are probably the most unclear out of all of them. So,
surprising for the Germans.
If I give you an example of a TT, and not the latest one, but the Mark II TT, it had a steel good floor, aluminium quarter panels. If you were doing a rear panel and a quarter panel, replacing both, you'd have 2 fresh bits of metal. That means the quickest way and the best way is to use a self-pierce rivet, which is quite happy finding their repair methods.
Yeah.
If, however, you were doing if you were just replacing the quarter panel, not the rear panel, you'd have a hole in the quarter and fresh bit of metal on the rear. So in this process, you would use a solid rivet where basically you're using the existing hole. So we've got the same type of panel, two different repairs and two different riveting processes being used.
So a solid rivet is just filling the hole then, basically.
Solid rivet is filling the hole. If you've got two fresh bits of metal, you'd use a self-pierce rivet.
Yeah. Okay. Seems
Loads,
like
loads of areas here to get yourself confused if you're not careful.
Yeah, that's what I'm thinking, Jerry. But you know, look at the methods. If the methods aren't clear, then either you or Pete will be on hand to give assistance, or if it's more specific, then the phone number is going to be at the end of this presentation. Give John a ring, and you'll simply get the answer quite quickly. Okay, ready to move on, John?
Yep. I think we've got some. So this is the countersinking of for the solid rivet. Do apologize, this video it is on steel, not aluminium.
Same effect though, I think.
Same effect, yes.
So
that's you can see there the head that we've used is the exact same shape as the solid rivet that's going to be inserted into the panel.
Okay, well, let's have a look at that now then. I think I would have dropped that rivet about 5 times by now.
I probably did, to be honest, when I was doing the video. Now, if you could see there in that video, you can see how it's shortening the rivet and it's starting to bulge to fill the hole.
Yeah.
So with this process on the other side, it's a lot neater because it's dead flush with the panel, like a self-pierce rivet or a spot weld.
Yeah.
However, go on,
sorry, go on, John.
What I'd say is the biggest issue with this type of riveting is because you're working on mostly aluminium vehicles. If you over pressurize the rivet, it can split the aperture because the rivet is being pushed in, it's expanding the inside. And if you over pressurize it, you can't split it.
What happens then? You got to put a new panel on, or
there is no technical method. If you've done it a few times, then possibly yes, you've got to put a new panel on. But remember that panel could be the inner panel. I think you've just got to use a bit of common sense. But before you do the riveting, the best thing to do is do some test pieces.
Right. And so how do you know what pressure to put on that rivet then to get it?
There is no, with Jaguar, that will give you the pressures of what to set the rivet to on that index. Right. But there is nothing there for Volkswagen Audi. So okay. It's a case of looking as you're doing it, as you're riveting, possibly do a test piece beforehand.
Yeah.
With a bit of the old panel, or can say set the rivet to a very low pressure.
Yeah.
Do it. If you think you need to go more, knock it up another step, do a little bit more, knock it up another step, do a little bit more till you get it right.
Okay.
Don't start high and work your way downwards.
Yeah. No, okay. That sounds like a sensible way forward on that one.
So in actual fact, you've got similar problems here to when technicians were asked to start MIG brazing. It was a different technique to mag welding, and they literally had to practice it to get the skill. And you're right. You're going to have to do the same thing here, aren't you?
Exactly.
Yeah. I mean, just took on that. So if you go for the training for self-piercing rivets and flow form, then I assume that will come up in the training anyway. Best
Correct.
practice on what to do that. Yeah. Okay.
Yeah.
Right. Tesla, Mr. Elon Musk.
Yes. So Tesla, they obviously aluminium vehicles. They basically use a mixture of blind rivets, self-pierce rivets, and flow foam rivets. So they are very much at sort of along lines of Jaguar Land Rover.
Right. And they do a bit of welding as well then.
And obviously a bit of aluminium welding as well, correct?
Yeah. Okay. Well, it keeps you on your toes. And where did you get training for Tesla?
I'll be honest, it's only Tesla that are doing the training themselves when it comes to. We do a lot of pre-training for the welding side before they go. But at the minute, all the Tesla training is being done at Thatcham.
Okay, cool. And then we're on to the training.
Yeah, so if you are ATA, it's not a new module, but it's been around for, Jerry, how long?
Nearly 2.5 years.
2.5 years.
Yeah.
The IMI have just put the AOM 133 into the panel reaccreditation. One thing that people do insist on, including ourselves who do it on site, is if we're doing this module, we do a pre-training day so that the technician does understand everything about the rivets before they do the qualification.
Yeah.
If they aren't ATA accredited, you can still do this module anyways, and it covers all the different rivets, and it's a nice qualification to have, and it will give you technician some lot more confidence.
Yeah.
And I'm right in saying that you can do this module on steel or aluminium.
Correct. That's right. Yes. And to be fair, Derry, it doesn't really matter because the processes are the same.
That's right. It's the processes that matter, isn't it?
Yeah, that's one thing I would say. If you know the process and have the information, it does look scary, but it's not once you have those two vital bits.
Okay, so how much would it cost for me to put one technician through this then?
To be honest, you'd be probably talking, because it's 2 days where we're on site. We try and do 2 technicians so it works out cheaper. But if it's say 1 technician, you're talking about 700 quid. But if it was two technicians, you'd be talking 500 quid each.
Right. Okay. And then, so long as they pass, then they can go on and use all the riveting tools and various processes that we've discussed through this webinar today.
That's right. Yes.
Right.
But they must have the pre-training as well.
Right.
Yeah. Well, that's what John's just priced up as well, I think.
And this, like I say, we do it on site, so it's a bit more expensive, because we come out to you. But it can be done at any training organisation in the country, where it will be a bit cheaper, but obviously you've got to travel to them.
Yeah, which may, yeah, you got hotel costs, travel costs, and all that type of thing.
Exactly, that's right.
Okay.
Right, this is before we play the video. If people ask what the future is, so our riveters I know can be upgraded. This is a prototype where we'll record the strengths and the forces that the rivet is put into, like with modern day spot welders.
Right.
So if we press the video.
Yes, sir. All right, you see the screen's changing with the amount of...
If you see.
That's
set
clever,
to 74. Exactly.
Yeah.
Now that will then be recorded against a job number, etc., and basically give you full accountability.
Yeah, I like that. I like that a lot. So if say that vehicle was involved in an accident and they wanted to make sure that the last repair process was correct, you just pull that out and say, that's how many rivets went into the job, these are the types of rivets, that's the type of Newton pressure that's been placed on the rivets, and it's all as per the vehicle manufacturer's methods.
And the one last thing, there'll be more things recorded, but it'll even record the humidity that the rivets were put in that. And that is more down to bonding glue.
Okay, so that's the bottom one on the list there, yeah?
Yeah, that's right. And also the room temperature.
Yeah.
Which is something really important to mention is when you are using these bonding glues, which obviously 3M, etc., and Terrason are better of giving advice on the different glues that's been used.
Yeah.
It is vital when you're putting these panels on to have it correct for the glue to cure.
Yeah. No, cool.
In other words, a cold workshop isn't acceptable.
No. Unfortunately.
But again, I assume that's in the methods as to what temperature that it needs to be repaired at. Again, if there's any queries on any of this, then please pick up the phone to either John, Jerry, Pete, or myself, and we'll help you through. That looks pretty space age, John. And I think that, with the way work providers are asking for accountability on repairs at the moment, I can see that being very useful.
Yeah. And I know it's something that manufacturers are looking at as well. Yeah.
Cool. I just wanted to see it again.
Yeah, not a problem. See, it was set to 74 kilonewtons.
Yeah. Humidity 29%.
See the green lights flashing.
Yeah. That's cool.
Yep. That will be where riveters move to the future.
Okay. All good. Right, no questions have come through as yet. Yeah, no questions have come through as yet, John.
Right.
I think it's quite a comprehensive presentation that you've given. Absolutely. So, Jerry, have you got any questions? Because you've usually got loads of questions.
No, well, obviously I have quite a bit of experience in dealing with stanners and with riveting methods and so on, and you've covered it very well, but it's one of those subjects that you're frightened of it until you get involved in it and get the knowledge, and when you've got the knowledge, the fear disappears, doesn't it? I
agree, and all I'd like to say is everything is constantly changing.
Absolutely.
Yeah. And if you haven't got any questions today, that's absolutely fine. If you want it to be a one-to-one question with John, pick up the phone. That's his email address, and it goes straight through to John. That's his telephone number, and he's inviting questions, calls, because he just wants to help the repairs move on through the future. John, have you got any questions from me or Jerry?
No. I think, like I say, I think I've pretty much covered everything that's in my mind.
Yeah.
So,
okay. Well, this webinar will be recorded and it will be put up onto the MBRA website, and it will be found by the Stanners partnership, but it will go into our current webinars as well. And we've got one question. Right, the suspense. Could or does a crib sheet be given to members for each OEM, and what type of rivets used? That's one for you, Jerry, I think.
Well, I think that would be something we would have to try and produce with the help of John.
Yeah, I know that one's come from Mr. Eden, so you're trying to stir the water there. I think if a member needs specific requirements for a job, then pick up the phone to either Jerry, Pete, me, or John, and we'll help you through that. We can have a look at doing a crib sheet for all the rivets, but I think because the landscape's forever changing, it would need a constant update. Is my only concern, Pete. But it is a good question, mate.
That would be my fear as well, as things are being constantly updated. For example, Audi didn't really use solid rivets. They always used self-pierce rivets. Then they went to solid rivets. Only in the past 6 months since the Defender's come out, Jaguar Land Rover were always using self-pierce rivets and blind rivets, and now they've just started to use flow form rivets. And I never really, and it was the 4-door saloon Jaguar. I forget which model it is, but the saloon one.
Yeah.
And helped the customer out on the repair, and it was only 4 rivets, but and I've done that job before where it's self-pierce beforehand. Jaguar's changed it to flow form rivet.
No. Yeah, so I think it's forever changing. So that is the only question. Listen, John, thank you very much for joining us today. It's been riveting, right? And the fusion has been remarkable. Jerry, once again, thank you for joining us. But I'd like to thank Stanners as a whole for being a partner supplier with the MBRA. And I'm sure we'll be doing another webinar later in the year, John. So if you missed it, it's going to be on the website. Thank you very much for your time today. And thank you, gentlemen.
Thank you.
Cheers. Thank you.
Bye.
Bye.